All right, welcome back to the deep dive. Today we're looking at one specific piece of gear. It's an environmental sensor.
Yep, the NTI E-WSS wind speed sensor, or, an anemometer.
Right.
And our mission here is pretty simple. Quickly get to grips with what it is, why it's built the way it is, and how it fits into NTI's bigger monitoring systems.
You mean like their E16D and E5D hubs?
Exactly. The whole ecosystem.
Okay, so the first thing that jumped out at me from the sources is how they market this. It's a rugged anemometer, and it's not just talk. It's got a 2-year warranty, and it's TAA compliant.
And that TAA part is a huge tell. It means it's approved for U.S. government use, which, well, that's a high bar for quality and reliability.
So when they say rugged, they really mean it.
Oh, absolutely. I mean, you just have to look at what it's made of. The body is Delrin.
That's that high-performance, super durable plastic, right?
It is. And crucially, it uses bronze and Rulon bushings inside.
So not cheap plastic on plastic parts.
No. This is all engineered for, zero maintenance out in the field, even when it's spinning like crazy in a storm.
And the part that actually spins.
The cups?
It's a classic 3-cup rotor, but it's pressed onto a solid stainless steel shaft. Again, it's the materials that make the difference. This is industrial-grade stuff.
Okay, so how do you mount it?
It's pretty straightforward. It comes with a flat aluminum mounting bracket. You just bolt it on top of a pole or some other structure.
And they include wire?
They do. 100 feet of exterior-grade wire right in the box, which is a nice touch. Shows they're thinking about the actual installation process.
Okay, so it's built like a tank, physically, but how does it actually, turn wind into data?
It's actually brilliantly simple. It uses a reed switch and a magnet.
So no complex optics or anything?
Nope. For every single rotation of the cups, the magnet passes the switch and creates one clean electrical pulse.
And the NTI system just counts those pulses. Exactly. It's all about reliability. They traded maybe a tiny bit of precision for something that is almost guaranteed to never fail in the field.
Let's talk about the performance specs, because one number really stands out.
The speed range.
Yeah. It says it can handle up to 125 miles per hour. Plus.
I know, it's pretty extreme.
Who needs to measure wind speeds that high? 200 kilometers per hour. Are we talking about like hurricane monitoring on an oil rig or something?
That's exactly the kind of application. Or military bases, huge broadcast towers, critical infrastructure in exposed areas, places where failure is not an option.
So it's designed for the absolute worst-case scenario.
It is. The rotor itself is 5 inches in diameter, which gives it a good capture area for that whole range, from a light breeze around 3 miles per hour all the way up.
And if you're on one of those huge industrial sites, you're not limited by that 100 feet of cable.
No, not at all. The maximum supported length is 1,000 feet.
Wow, over 300 meters.
So you can place these sensors pretty much anywhere on a large campus and run it back to the main unit without any boosters or anything.
So let's connect this back to the bigger picture you mentioned.
Yeah.
The EWSS isn't a standalone device.
Right. It's just one data point. It plugs into the NTI ecosystem, which can monitor, well, almost anything.
And their sensor list is huge. I mean, the sources mention an optical dust sensor.
Yep. The EDD.
A noise level sensor, a light intensity sensor. Even a fence vibration sensor.
See? So now you're not just measuring wind, you're building a complete real-time profile of an entire environment.
It's a much richer picture of what's happening.
A comprehensive one, yeah.
So to wrap this up, what have we got? The NTI E-WSS is a highly specialized anemometer. It's built for extreme conditions, measures incredible wind speeds, and it's designed from the ground up to be one piece of a much larger monitoring puzzle.
Exactly, and that leaves you with a really interesting final thought. Well, if you have all this data, wind speed, dust, noise, light, even fence vibrations all flowing into one system, what kind of weird patterns could you find?
What do you mean?
I mean, what new insights pop up when you can see a 90-mile-per-hour wind gust correlated exactly with a vibration spike on a fence a quarter mile away? That's where the real intelligence is hiding, in connecting the dots.